It looks like something from a sci-fi film, a tracked machine slicing through sandy soil with surgical precision. But this isn't fiction. This is modern Chinese agricultural innovation at its finest. In regions where crops once failed, farmers now thrive thanks to this powerful disc cutter vehicle. And if you think that's impressive, just wait until you see what it can really do. Subscribe now, because only at the end will you understand what makes this machine so revolutionary. What is this machine? It moves slowly, but with purpose, a tracked vehicle unlike any ordinary tractor. At the front, a massive disc cutter spins, slicing through the dry, compacted earth of northern China. This isn't your average farming equipment. It's a purpose-built, all-in-one agricultural powerhouse designed for extreme environments. A new breed of farming vehicle. This tracked machine features a wide steel disc cutter mounted on its front, engineered specifically to deal with sandy, infertile soil, the kind that would clog or wear down traditional plows. The machine is fully equipped to cut, churn, and plant seeds in a single pass, reducing time, labor, and fuel consumption significantly. Its robust caterpillar tracks give it a low ground pressure, allowing it to glide across unstable terrain without sinking or stalling. Built for harsh conditions. In regions like Inner Mongolia and the arid plains of northern China, the ground is dry, loose, and often considered useless for traditional farming. Normal tractors would either break down or fail to achieve the necessary soil penetration. That's where this machine comes in. It's not just adapted, it's specialized. Using hydraulic-controlled depth systems and powerful torque, it can process land that was previously abandoned due to soil failure. 3 actions in one motion. The brilliance of this machine lies in its efficiency. As the rotating disc cuts into the ground, it simultaneously turns over the soil and lays down seeds. Some variants even include nozzles to deposit water or fertilizer into the freshly made furrows. This integrated process increases planting density, reduces erosion, and maximizes water retention, crucial in drought-prone regions. Compared to traditional tractors require multiple passes, one to till, one to sow, and one for fertilization. Each pass costs time, fuel, and increases soil degradation. In contrast, this disc cutter beast reduces soil compaction, minimizes dust, and dramatically lowers operation costs. It's no wonder local farmers and agricultural engineers see it as a revolution for tough terrains. Why is the ground so problematic? In the remote farmlands of northern China, where traditional agriculture has long struggled to survive, this machine has begun to shift the future of food production. It's not just about cutting through sand or sowing seeds. It's about reshaping how rural communities interact with land once deemed useless. The tracked disc cutter machine doesn't simply function, it transforms. Farmers, who once relied on unpredictable weather and labor-intensive methods, are now seeing a revolution in how quickly and efficiently crops can be planted, even under hostile conditions. This isn't just a local solution. It's part of a larger national strategy to combat desertification and increase self-sufficiency. With China's increasing demand for grain and decreasing availability of fertile land, innovations like this are not just welcome, they are necessary. In places like Inner Mongolia and Ningxia, entire pilot programs have been launched to deploy these machines on a regional scale. Results are already visible. Crop yields have improved by up to 30%, water usage has decreased, and previously uncultivated plots are producing harvests for the first time in decades. The machine's impact extends beyond agriculture. Local economies are benefiting. The reduced need for multiple vehicles and labor inputs means lower production costs, making farming more profitable and sustainable. Workshops are emerging to maintain these machines, new jobs are being created in rural areas, and communities are gaining a sense of resilience in the face of climate extremes. Additionally, by minimizing the number of passes needed across a field, the machines lower carbon emissions, contributing to China's broader ecological goals. What's particularly fascinating is how these machines are customized to local conditions. Sensors adjust cutting depth in real time, GPS systems optimize planting paths, and modular attachments allow for different crop types. This isn't a one-size-fits-all approach. It's tailored innovation, grounded in real-world farming needs. Where conventional tractors sink or fail, these machines glide, adjust, and deliver. Their success has caught the attention of agricultural engineers worldwide. Countries facing similar issues, like Kazakhstan or Sudan, are already exploring partnerships to import or adapt the technology. What started as a local response to environmental adversity may well become a blueprint for farming on marginal land globally. The engineering behind it. The engineering behind China's tracked disc cutter machine is a blend of simplicity and sophistication, designed to withstand harsh conditions while maximizing efficiency. At first glance, the machine resembles a compact armored tank. But beneath its rugged chassis lies a well-coordinated system engineered for a very specific purpose, making sandy, barren land farmable. Its base is a caterpillar-style tracked platform that provides stability on soft terrain. Unlike wheeled tractors, which tend to sink or lose traction in sandy soil, the wide tracks evenly distribute the machine's weight and offer excellent grip, allowing seamless movement across otherwise inaccessible farmland. At the heart of the operation is the disc cutter mounted at the front. These rotating blades slice through compacted layers of sand and hardened crust with ease, using both rotational force and vertical pressure. The engineering challenge here wasn't just about creating a powerful cutter, it was about crafting one that could adjust dynamically to changing surface conditions. That's why the blades are often mounted on pivoting arms, equipped with pressure sensors that adapt the force depending on resistance, reducing wear and energy consumption. Behind the disc cutter is a synchronized plowing and seeding mechanism. As the soil is sliced open, a follow-on blade system loosens it further, creating the ideal conditions for planting. A smart seeding unit then deposits seeds directly into the prepared furrow. Some versions of this machine are also fitted with a drip irrigation nozzle, delivering small amounts of water with pinpoint precision to help seeds germinate faster. This all-in-one cycle cut, plow, plant, irrigate isn't just elegant, it's efficient. It significantly reduces the time, labor, and fuel needed for cultivation. In terms of power, the machine typically uses a high-torque diesel engine optimized for low RPM and extended operation. Because it must often function far from repair stations or spare parts, the design prioritizes durability and ease of maintenance. Hydraulics are simplified, and electronic controls are minimal, reducing the risk of breakdowns in remote locations. Altogether, this is more than just a farming tool. It's a customized engineering response to climate challenges. It proves that when design meets necessity, even the toughest landscapes can be transformed into productive farmland. Impact on rural communities. The deployment of this tracked disc cutter machine is more than just a technological milestone. It's a lifeline for many rural communities in China. In provinces like Inner Mongolia and parts of Gansu and Ningxia, where vast stretches of land have been deemed too sandy or arid for traditional farming, the machine opens doors that had long been shut. These are areas where small-scale farmers once relied on outdated methods and faced low yields, forced often into migration or debt. With the introduction of this all-in-one agricultural unit, many of these families can now farm land that was previously unusable, potentially reversing decades of economic stagnation. In real terms, this translates into job retention and even creation. A single machine operator can now manage tasks that used to require several workers. While this may seem like a threat to manual labor, in practice it shifts labor roles rather than eliminates them. Local youth are being trained to operate and maintain these machines, creating a new layer of skilled labor within these communities. Moreover, seasonal workers can now focus on more productive stages of agriculture, such as harvesting and post-processing, rather than exhaustive plowing under brutal sun. One of the most transformative effects is food security. With increased arable land, these regions are beginning to grow not only basic grains, but also specialty crops that thrive in sandy soil, such as peanuts or certain types of melons. This allows communities to tap into niche markets, increasing both income and local food diversity. Governments are even offering subsidies to cooperatives that adopt the new technology, recognizing its potential to uplift entire districts economically. There's also a subtle but profound shift in local mindset. Farmers who had long given up on their land are returning to it with renewed hope. Children see their parents staying home rather than migrating for work, and schools in these villages are reporting better attendance. While the machine is metal and mechanics, its impact is deeply human. It restores dignity, purpose, and stability to places once forgotten. Global recognition and export potential. The unique agricultural demands of China's northern regions have led to the development of one of the world's most innovative farming machines, but its potential extends far beyond China's borders. As the global population rises and climate change accelerates, nations across Asia, Africa, and even parts of Europe are beginning to take note of the machine's capabilities. Countries with similar environmental challenges, such as sandy or degraded soils, are exploring how this tracked disc cutter could revolutionize their own farming systems. In recent international agricultural expos, including the China International Agricultural Machinery Exhibition and the Asia-Pacific Smart Agriculture Summit, delegations from countries like Egypt, Sudan, and Kazakhstan have expressed interest in the technology. These regions share similar issues with desertification and nutrient-poor soil, making the Chinese model particularly relevant. The ability to plow, loosen, and seed simultaneously in one efficient pass has attracted attention not just for its productivity, but for its ability to conserve fuel, water, and labor in remote environments. Chinese manufacturers are now scaling production not only for domestic needs, but also for export. Pilot programs have already begun in parts of Central Asia, where adapted versions of the machine are being tested under local conditions. Early feedback indicates that minor modifications, such as changes to blade depth or cooling systems, can make the units viable even in harsher or hotter climates. With this feedback loop in place, manufacturers are preparing export-ready versions tailored for specific regional needs. The geopolitical implications are also worth noting. As China continues to expand its Belt and Road Initiative, agricultural technology like this disc cutter could serve as a soft power export. It fosters cooperation, technical exchange, and infrastructure partnerships with developing nations. At the same time, it positions China not only as a producer of consumer goods, but as a provider of sustainable, high-tech agricultural solutions, a reputation that could shift the dynamics of global food security efforts. The disc cutter's journey from dusty northern fields to potential global acclaim is a powerful reminder that some of the most significant innovations come from the margins. With the right support, this machine could play a key role in the next generation of sustainable agriculture, one rugged trench at a time. Final thoughts and global significance. As this rugged tracked machine carves through the unforgiving sands of northern China, it becomes clear that we are witnessing more than just clever engineering. This disc cutter represents a shift in how we approach food production in the face of environmental adversity. It's not only a marvel of mechanical design, but a symbol of adaptive resilience, of how humans can respond to nature's challenges with precision, grit, and innovation. The machine's ability to operate autonomously across difficult landscapes while performing multiple tasks in a single pass transforms not just efficiency metrics, but entire agricultural strategies. For farmers battling desertification or poor soil fertility, this is more than a machine, it's a lifeline. It drastically reduces labor intensity, maximizes time, and conserves vital resources like fuel and water, which are often scarce in these regions. Globally, as climate unpredictability continues to reshape arable lands, such innovations are no longer optional. They are essential. Other countries facing similar conditions are already watching closely. Whether it's the Sahel in Africa, inland Australia, or parts of the Middle East, the need for such robust solutions is universal. In a world where feeding populations sustainably has become one of our defining challenges, this machine is a glimpse of what's possible when necessity meets ingenuity. While it began as a tool tailored for one country's unique topography, its future may very well be global. The question is no longer whether such machines will be needed elsewhere, but how fast they can be shared, adapted, and improved. In that sense, this dusty, crawling machine isn't just digging into soil, it's digging into the future.